What do you see about what's different about this type of two-step equation versus what we did yesterday? There's a fraction. Perfect. So notice if we looked at it just like this, it looks like a division problem, right? It looks like one of the single one-step equations. It looks like a division problem. So our first step is going to be the same. We're going to add or subtract our constant. So our first step in this type of problem is going to add or subtract our constant. And I shorthand looking at the side, and here's my variable over here. Looking at the side where my variable is, what is my constant? Is my constant the 4 or the -3? You think it's a -3, Reed? No. Absolutely, I positively agree. So how do I get rid of that -3? We're going to add 3 to both sides, and you'll see that that's what we did. So we added 3 to both sides. I'm just going to highlight it here. When we add 3 to both sides, on the left side it's going to cancel out, and we'll be left with just n over 4 equals 10, because 7 plus 3 is 10. Okay? Our second step, you will notice, is to do what? How am I going to get rid of? It's n divided by 4. So what is the inverse operation of dividing by 4? Dylan? Absolutely, we're multiplying by 4. So our step 2 is to multiply both sides. And what am I multiplying both sides by? What do we call that number on the bottom? What do we call this number? Yes, very good. The denominator. Okay. So we multiplied both sides on the left. That will cancel out, leaving us with just n. So you'll see our n just comes down. And then on the right-hand side, 10 times 4 is 40. So we got a value for n. It's always good to check your answers. So what I'm going to do is to plug 40 back in for wherever I see n. So it's going to look like 40 over 4 minus 3 equals 7. If I go into my calculator and I were to do 40, what is 40 divided by 4? 10. Good, so that simplifies to 10 minus 3 equals 7. 10 minus 3 is 7. Does 7 equal 7? Is that a true statement? Yes, it is. So we know we got our answer correct. So from yesterday to today, what is the only difference that we're doing? There's one slight small step that we're doing differently than we did yesterday. Yesterday, what were our steps? To do what? Yesterday we added or subtracted our constant, and our second step was to what? Not to multiply, was to divide. Today, our first step is still the same. It's still to add or subtract our constant, but now we're multiplying by the denominator. Okay, so let's look at our next. Sure, go ahead, take a minute. Try this on your own, and then we'll go through it. Okay. What? Absolutely.
It is the same thing.
My first step doesn't change. I'm still going to add or subtract my constant, depending on what my constant is in this equation. My constant is a -17. Reed, how do I undo a negative 17? I'm going to add 17. Good. To both sides. What you do to one side, you must do to the other. When I do that, on the left-hand side, my 17s will cancel out. And that entire thing with the variable comes down. So now it's going to look like n over negative 6. Looking on my right-hand side, 4 plus 17 gives me 21. Now, looking back at the previous slide, what was my step 2? What do I have to do for step 2? I have to do what to both sides? By the denominator. What is my denominator in this equation?
6.
No, it's
Negative.
not. There you go. Thank you. It's negative 6. It's super, super, super important that you recognize that's a negative 6, okay? So you must multiply both sides by negative 6. Okay? So when I multiply both sides by negative 6, on the left, it cancels out. 21 times negative 6 gives me a... Is it 126? All right. So our step 2, again, I'm going to write this, was to multiply both sides by the denominator. So looking at example 7, first, what did I do first? Leah, what did I do first in example 7?
You brought down negative
Good, and so I subtracted 2 from both sides, absolutely. So I subtracted 2 from the left side, and I subtracted 2 from the right side. When I did that, my a over 6 was brought down, and then I did 5 minus 2 on the right, which gave me 3. What was my second step? Darrell, what was my second step?
We do 3 times 6.
But why? Why am I, you're absolutely correct, I'm multiplying 3 times 6, but why am I multiplying 3 times 6? There's a reason for it. How do I, why, where is this 6 coming from? Where did you find that?
It came from
Start with the D.
there.
Yes. Here, my A is being divided by 6. So my second step in this equation, or to get A by itself, is to multiply both sides by the denominator. Okay, so I multiplied both sides by 6. When I did that, my 6's canceled out, and all I was left with was A. And looking on the right side, 3 times 6 is 18, so that was my final answer. How did I know I was done? How did I know I couldn't go any farther? What's my end goal?
To get down to simplest form and
I agree, but what did I just say? What do my variables want? To be alone. Is my variable by itself? Yes. So that's why I know I'm done. I can't go any farther. Okay. I would like try the example on your own, and then we're going to go over it. All right, go ahead.
okay, so first you would put your negative 10 right here,
Good.
both sides. And then you would draw your line under here. And these two will cancel out.
Good. Your 10s cancel out.
And then you'll subtract 30 minus 10,
Good.
which gives you a 20,
Perfect.
and you'll do this, and then you'll put your 2 in parentheses over here,
Mm-hmm. Because you're multiplying both sides by the denominator. Good.
and then these two will cancel out,
Yep.
and you'll put the x right here in your equal sign, and then 20 times 2 equals 40.
Perfect. Absolutely wonderful.